Hi, welcome to Raw Math. Today I'm doing a series of videos on linear programming. What we're trying to do is we're trying to minimize this equation subjected to these equations. The way we're going to do this is we're going to graph these four lines, find out where they intersect, and the intersection points will be plugged into the function we're trying to minimize. The intersection points will create the smallest value. So even though these are inequalities and there's going to be an infinite number of points that work for all of these four equations, there's only going to be one that will minimize it, and it will be one of the intersection points. Okay, so I'm going to start off with graphing the lines. 5x plus 3y, I'm going to say equals 195. I could leave the inequality in there, but I don't really need to because this is just to graph the line. So the inequalities sometimes get in the way. If we just do the equal sign, we can quickly look what our line looks like, and because they all have an equal sign as part of the inequality, they're all going to be solid lines. Okay, to graph this line, I'm going to graph the intercepts. So if I set y equals to 0, then x is going to be 195 divided by 5 is 39. If I set x equal to 0, then y is equal to 195 divided by 3, or 65. For my second line, I have 4x plus 5y equals 260. If I set y equals to 0, then x is going to equal 65. And if I set x equal to 0, then y is going to equal 52. Okay, so then what I'm going to do is I'm going to plot these points, but I'm not going to worry about scale. So I'm going to have a 39 and a 65. I'm going to have a 52 and a 65. Most of the times these two lines will cross in the first quadrant, but it's always good to double check. So 39 and 65 go together. So I'm going to connect these two. And then 52 and 65 go together. So I'm going to connect these two. Okay, because these are both greater than or equal to, I'm graphing above the line here and above the line here. So I know I'm out here in this big open quarter of my field. My last two constraints, x is greater than 9, so I'm just going to put in a 9 here, and we have to be greater, so there's another intersection point. And y is greater than or equal to 11, so I need to put in a line for 11, and I have a last one. So now we know that we are in this series of points. Anything in this series of points will meet all four of my conditions. So that's a lot of points. As it goes, I only need to worry about 3 of them for my testing, which is pretty cool. So I need to figure out what those intersection points are. I'm going to start with the hard one. The hard one is where these two lines intersect. And to figure out where those two lines intersect, I have to solve the system of equations. So what I'm going to do is I'm going to say 4 times the first line minus 5 times the second line. And when I do a subtraction, I always multiply through by the negative. I find that that makes it simpler to add everything and get the right answer. So 4 times line 1 is going to be 20x plus 12y equals 780. Negative 5 times line 2 is going to give me a negative 20x minus 25y equals a negative 1300. And when I add down, I'm going to get that negative 13y is equal to negative 520. And then when I divide, I get that y is equal to 40. I then need to use that to get my x. So I'm going to go back to my original equation. I'm going to say 5x plus 3 times 40 equals 195. 5x plus 120 equals 195. Or 5x, let's come up here, 5x is equal to 75. So x equals 15. I then quickly check, is 4 times 15 plus 5 times 40 really equal to 260? It is. So this point right here is 15, comma, 40. To figure out the other two is a little bit simpler because we know for 9, all we need to do is put 9 in for x and figure out what y is. So if I take 5 times 9 plus 3y equals 195, 45 plus 3y equals 195, so 3y is equal to 50. Sorry, 150. So y is equal to 50. So that means this point right here is 950. Okay, and then for my last point, I have y is equal to 11. So for this one, I'm going to say 4x plus 5 times 11 equals 260. 4x plus 55 equals 260. 4x is equal to 205, or x is equal to 51.25. So this point right here, let's go this way, is 51.25, comma 11. So now we have the 3 corners of our graph, and we take each of these corners and we test them with our equation to see which of these 3 corners minimizes the equation. So what I'm going to do is I'm going to take my first point, which is 950, and I'm going to plug it in. Z equals 670 times 9 plus 430 times 50, and I get that this is equal to 27,530. Then I'm going to take my second point, 1540, and I'm going to say Z is equal to 670 times 15 plus 430 times 40, which means this is equal to 27,250. And lastly, I'm going to say 51.25, 11, test that. Z is equal to 670 times 51.25 plus 430 times 11, which comes out to 39,067.5. And when we look at these numbers, we see that this is my minimum value. So for the answer, I'm going to say the minimum is Z equals 27,250 at 1540. And this will be my final answer. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!